It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Okay, good evening, my dear students. Welcome. Welcome to Unacademy, the largest online platform, my dear students. Okay, myself is Dr. Bian Rao, having 17 years of the pure teaching experience, my dear students. Okay, out of that, 17 years of the pure teaching experience, my dear students. Out of that, from the last 10 years, I was supposed to be teaching the various subjects, my dear students, in the departments of ECE and instrumentations, the subjects like communications, core instrumentation, electronic device and VLSI design, my dear students. Okay, and for the gate and engineering services level competitive level examinations. Okay, recently I have received the PhD in the department of ECE under low power VLSI design from one of the reputed University of Andhra Pradesh, my dear students. Okay, and these are the general things just I would like to bring it to your notice as far as mine is concerned. And nearly I dealt 200 plus batches across all the locations of the India, across all the locations of the India, my dear students, as far as okay, as far as the Unacademy itself is concerned, my dear students. And not only delivering the various batches, my dear students, the way of executing the seminars and webinars throughout the India, mentored 10 plus K students throughout the India, my dear students. Okay, similarly, when it comes to the Unacademy subscriptions, there are two important subscriptions are there in the Unacademy. One is called the iconic subscription. If you are going to take this particular subscription, a personal coach is dedicated for each and every student. He will explain the subject in a detailed study manner. Okay, explain the subject in a detailed study. Okay, with respect to the basics to the till and the problem solving, my dear students. Okay, moreover, you are going to receive the expert guidelines from the topmost educators of the Unacademy, and the mains level guidance also you are going to get over here as far as the iconic subscription is concerned. Similarly, when you are going to take the plus subscription, my dear students, you are going to access the live live classes from the topmost educators of the Unacademy. Okay, and also you can practice the unlimited test series over here with respect to the detailed structured timetable. My dear students. Okay, these are all the two important subscriptions that plays a vital role, my dear students, as far as the Unacademy is concerned. Okay, Unacademy is concerned, my dear students. Okay, similarly, when comes into the fee structures of these particular subscriptions, it plays also vital role, my dear students. Okay, and these particular subscriptions for plus for GATE and engineering services for 12 months 27,225, and you can use my code and get the discount. Okay, similarly for 18 months for the same plus subscription, the fee structure is 34,650, and you can use my code and get the discount. Okay, similarly for 24 months for the same plus subscription, 39,600, and you can use my code and get the discount. Okay, these are all the plus subscriptions. Okay, similarly when comes into the iconic subscription for 12 months, my dear students, the fee structure is 45,225, and you can use my code and get the discount. Okay, similarly for 24 months the fee structure is 66,600, and you can use my code and get the discount, my dear students. Okay, similarly the plus batches taken by the topmost educators inside of these particular Unacademy subscriptions. Okay, here are the batches that are going to be taken inside, my dear students, various faculties. Okay, in the departments of electrical and ECE, my dear students. Okay, target engineering services prelims 2021 electrical batch D, December 7th, my dear students, already it has been started. Okay, similarly rank booster batch for GATE 2021 batch D, November 30th, target engineering services prelims 2021 batch C, and rank booster batch for GATE 2021 batch B, my dear students. Okay, these are all the batches that has been taken by the various faculties. Okay, similarly Ascent for GATE 2023, my dear students, this is also taught in English and Hindi. ECE batch A, my dear students. Okay, starts on 21st of the December. Okay, similarly one more batch Ascent for GATE 2023 for electrical batch A, English and Hindi, my dear students, 21st of the December. This is also started in the last week. Okay, similarly Evolve for the GATE 2022, my dear students, this batch has been started, my dear students, and this batch is also electrical batch, my dear students. Okay, that is also 21st of the December. Similarly Evolve for the GATE 2022, my dear students, this is also taught in the English and Hindi. It is also starting on the 21st of the December, my dear students. Okay, similarly the GATE crash course into the Unacademy Telugu channel, my dear students. These are all the list of the faculties who are going to teach you the various subjects, my dear students. Like the Bhim Shankar sir is teaching the networks and digital electronics, and Professor Krishna sir is teaching mathematics and foundation mathematics, and the Professor Sharma sir is teaching, my dear students, aptitude, and myself in weekdays I am teaching communications, weekend CDC, and Bhanu Prakash sir along with one more faculty like Surendra sir is teaching the core subjects of the electrical, my dear students. Okay, similarly Unacademy Telugu channel December month schedule, my dear friends, for communication systems 4 p.m. to 5:30 p.m. and electrical machines 4 p.m. to 5:30 p.m. engineering mathematics 5:45 to 6:45 p.m. power systems 7 p.m. to 8 p.m. and aptitude, my dear students, 8:30 p.m. to 9:30 p.m. my dear students. Okay, weekdays, weekends, the subjects like power electronics 4 p.m. to 6 p.m. EDC 4 p.m. to 6 p.m. aptitude 7 p.m. to 9 p.m. my dear students. Okay, these are all the batches that are going to be handling by our particular faculties, my dear students. Okay, similarly EDC, I told you that Saturday and Sunday this particular course has been going on and it is moving on. Okay, and these timings are Saturday and Sunday from 4 p.m. to the 6 p.m. my dear students. Okay, these are all the general things just I would like to bring it to your notice before entering into the subject. Okay, similarly Unacademy, again one more compact is going to come on December 29th at 6 p.m. my dear friends. India's largest again fortnight competition for the GATE, my dear friends, and challenging questions created by the best educators for this particular combat, and this is also super fast and the fun with the real-time rankings, my dear students. Compete with the best and detailed video solutions by the topmost educators. Again, the prices has been distributed, my dear students. Similar prices also this time. The prices and the prices itself is going to be changed this time from rank 1 and 3. 3 months subscription of the Unacademy, okay, or you can go for the using of any particular Emotion voucher, okay, or ESE subscription of equivalent of Emotion voucher, or rank 4 to 50, my dear students. 500 rupees Amazon voucher that they are going to give, my dear students, if you are participating in this combat, my dear students, okay. Similar way, Unacademy combat, my dear students, okay, which is also this combat which I told you, okay. So this particular combat also the same thing, 3 months, okay, subscription or equivalent Amazon voucher, my dear students, okay. Similarly, rank 4 to 50, 500 rupees Amazon voucher, my dear students, okay. These are the general things, just I would like to bring it to your notice, okay. And my dear students, already I have completed maximum, that is the special purpose electronic devices, okay. Special purpose electronic devices I have finished about the optical sources like LED, fundamentals of light, and lasers, my dear students. I finished all these particular concepts here in the previous, okay, classes, okay. Now in this particular session I am going for the very important topic, optical detectors also I have started, my dear students, and I finished the last class, that is semiconductor photoelectric transducers, LDR or photoconductor or photoresistor. This is also finished, okay, my dear students, and LDR construction is finished, LDR characteristics also finished, my dear students, types of LDRs also finished, applications of the light dependent resistors also finished, and PN photodiode also finished, my dear students, okay. Now in this particular class I am going for the next concept, and that particular one is called very important one, okay. That one is called PIN photodiode, okay. This is the PIN photodiode, my dear students. We are going to study in this particular section, my dear students, okay. Very important one. So how we are going to study this particular one? Generally I am going to explain this concept in a detailed manner, okay. PIN means it is having the 3 pins, okay. It is a, see, here we are going to having the 3 layered, okay. Generally what is a PN photodiode? PN photodiode having only the 2 layers, P and N, okay. But here onwards it is very important, PIN photodiode, okay. I told you the optical detectors are 4. What are the optical 4 detectors, my dear students? I told you light dependent resistor, first one. Next one is called PN photodiode. Next one is PIN photodiode. Next one is avalanche photodiode, my dear students, okay. Avalanche photodiode, my dear students, okay. All these are very important over here, my dear students, okay. Now in this one we have completed the first 2. Now in this class we are going for the PIN and avalanche photodiode and the basic numericals that has been asked in the previous papers. Then we are entering into the Zener diode, the one more diode, my dear students, okay. So all these are very important, not only at the gate level for EDC but also for the engineering services level, my dear students, okay. Similarly, now I am going for the first one is what, my dear students? PN photodiode, okay. PIN photodiode, my dear students, okay. Why we are going for the PIN photodiode? When you are having PN photodiode, okay. When you are having the PIN photodiode generally, so PIN photodiode, if I am going to take it, my dear friends, this is a 3-layered semiconductor, my dear students. It is having the 3 layers. It is having the 3 layers, my dear students. See my dear friends, okay, this is what this is P layer and this is N layer my dear friends. Here there is one more region called intrinsic region. అంటే మనం PN photodiode తీసుకుంటే my dear friends, here అంటే PN photodiode లో ఓకే మేబీ రెడ్యూస్డ్. ఓకే నేను ఏం చేస్తాను, జనరల్గా PN photodiode తీసుకుంటే see here by decreasing the width on the P side and N side. ఓకే అంటే PN photodiode లో ఏముంటుంది, the widths are more. Okay, the widths are more my dear friends. Okay, and the diffusion component, okay, what are the diffusion component that is present in PN photodiode, that is present in the PN photodiode my dear students. Okay, that is present in the PN photodiode may be reduced by decreasing the widths of the P type material and N type material, increasing the width my dear students. Okay, అంటే నేను PN photodiode కు PN కి డిఫరెన్సెస్ చెప్తున్నాను. అంటే ఏం చేశాను, ఇక్కడికి వచ్చేసరికి ఈ యొక్క width ని పెంచాను. Okay, the width of the depletion region is going to be my dear students increased over here. Okay, then automatically what happens, the diffusion తగ్గుద్ది. అదే PN ఉందనుకోండి, P నుంచి N side, N నుంచి P side కి PN photodiode లో డిఫ్యూజన్ ఉంటుంది, మ్యాక్సిమం డిఫ్యూజన్ ఉంటుంది. ఆ డిఫ్యూజన్ ని తగ్గించాలి. In order to reduce that particular diffusion, then what happens, I will increase the width of the depletion layer my dear students. Okay, this is the width of the depletion layer my dear students. Okay, this is width is this one. Okay, so for that particular reason I am going to use this particular intrinsic layer which acts in between this P and N. At a PN photodiode it is nothing but the two layered semiconductor. It is nothing but the two layered semiconductor. Okay, PN is I already told you in the previous class, but it is a three layered semiconductor. It is what my dear students, three layered semiconductor. Okay, so here what happens, here also photodiode means here the photodiode, it is also a semiconductor photoelectric transducer. Means the light transducer is nothing but converting the one form of energy into another form of energy. Here the light energy is converting my dear students, the light is projecting over here, the light is making to the light energy is connecting to electrical energy. So here what happens, the light E is equal to H in U, the photon of the light my dear friends. Okay, that is following, okay, on this particular one. Okay, on this particular one, here what happens, more amount of the light is absorbed in this region because the width of the depletion region is more. So more amount of the light is absorbed in this particular region. The region where the more amount of the light is absorbed at that particular region is called absorption region. The name we are going to call it as a absorption region my dear students. Okay, the region where more amount of the light is my dear friends that has been absorbed over here. So here at most of the incident photons are absorbed here my dear students. Okay, see here what happens, and these particular whatever the intrinsic layer I am going to take it, and this particular intrinsic layer is always what type of doping we have done, means all these points are very important. It is lightly doped, and this particular region is a lightly doped. This is the region 1, this is region 2, and this is a region 3. Okay, always this particular region is a lightly doped region my dear students. Okay, so here what happens, a layer of the semiconductor that is lightly doped my dears, and it is acting as a, this layer is called I means intrinsic means pure form. Okay, intrinsic layer. Okay, and here what happens, this is inserted between P and N diode. That's the reason it is called as a PIN photodiode. That's the reason it is called a PIN photodiode my dear students. Okay, so here as a middle layer is here intrinsic in nature. It is intrinsic in nature my dear students. Okay, it is intrinsic in nature my dear students. So this middle layer offers always what, high resistance. Okay, it is offering what kind of resistance my dear students, it is offering high resistance. It is offering the high resistance, and the moreover whenever it is offering the high resistance V equal to IR, then what happens, here most of the voltage drop, that is what happens, most of the voltage drop occurs across it. So what happens, here the most of the voltage drop across it, voltage drop across it. I will show you why it is occurring my dear students. Okay, across it, my dear students. Okay, very important one this is. Okay, here then a strong exit. So because of this intrinsic region, one more important point itself is that the electric field is strong. The electric field is strong, my dear students. Electric field is strong, my dear students. Okay, is strong in this particular region, is strong in this particular region, my dear students. Okay, so then what happens, my dear students, whenever here more amount of the light is absorbed over here, my dear students, then what happens, the drift of the carriers, because of the more amount of the light, then what happens in a semiconductor, here what happens, what is happening, my dear students, means here this is in a semiconductor, what is there, this one itself is called conduction band, and this one itself is called valence band, my dear students. Then from here to here, what happens, electrons will jump, my dear students, from here to here. Then what happens, more and more electron and hole pairs are generated. Here again what happens, my dear students, more and more that is electron hole pairs are generated. Because of this electron and hole pairs, then the drift component of the photocurrent, means the drift of the current is taking place. So the drift component is taking place, my dear students. Okay, the drift component. So here the important point itself is that, once again, my dear students, ఇక్కడ ఏం చేయాలనుకుంటున్నాను, నేను ఒక ఇంట్రిన్సిక్ రీజన్ ఎస్టాబ్లిష్ చేయాలనుకుంటున్నాను. ఈ రీజన్ ఎస్టాబ్లిష్ చేయాలనుకుంటే ఏం చేయాలి, ఈ విడ్త్ ఆఫ్ ద డిప్లీషన్ రీజన్ పీ సైడ్ ఎన్ సైడ్ తగ్గించాలి, ఈ యొక్క విడ్త్ని పెంచాలి. ఫస్ట్ పాయింట్ యూ నీడ్ టు రిమెంబర్, మై డియర్ స్టూడెంట్స్. ఓకే, లైట్ ప్రొజెక్ట్ చేస్తే ఆల్వేస్ మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఈస్ అబ్జార్బ్డ్ ఇన్ దిస్ రీజన్. అందుకే ఈ రీజన్ ఏమంటారు, ద లేయర్ వేర్ ద మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఈస్ అబ్జార్బ్డ్ ఈస్ కాల్డ్ అబ్జార్ప్షన్ రీజన్ అంటారు. ఓకే, ఈ రీజన్ లో ఇట్ ఆఫర్స్ ద హై రెసిస్టెన్స్. ఓకే, మోర్ ఓవర్ ఈ రీజన్ ఏమంటారు, ఇంట్రిన్సిక్ రీజన్ అంటారు, బికాస్ ఇట్ ఈస్ ఆల్సో లైట్లీ డోప్డ్ రీజన్ అని కూడా అంటారు. ఓకే, ఇక్కడ స్ట్రాంగ్ ఎలక్ట్రిక్ ఫీల్డ్ ఉంటుంది and voltage drop across it very small. Okay, so because of the more amount of the light is absorbed, electron hole pairs gives rise to drift component. Okay, a drift component always greater than the PIN photodiode lo diffusion current kante, diffusion component kante ekku untundi, diffusion component kante ekku untundi. That's the reason here what happens, my dear students, the drift component of the photocurrent is dominating the diffusion component, as the most of the light is incidented in the intrinsic region, in this particular region, my dear students. Okay, and here also I am going to tell you how in this particular region how the curve is there. Okay, if I am going to tell you the curve, my dear students, so strong electric field, this is electric field axis, the electric field will be like this, my dear students. Okay, the electric field will be like this, my dear students. Okay, the electric field will be like this, my dear students. Okay, very important point. Okay, you need to remember over here. So what kind of regions are there? Okay, and this is always, this P region is always, my dear students, it is what kind of doping? Okay, it is simply, if it is normally doped, always this P region is normally doped, my dear students, and N plus region, and this region is always, my dear students, this is called heavily doped, heavily doped thin N plus region, thin N plus region, my dear students. Okay, so as a result of that, what is flowing over here, the photon current is flowing, the current is called photon current, my dear students. Okay, photon current is flowing, my dear students. Okay, Usha, photon current is flowing, my dear students. The photon current is flowing, my dear friends, over here. Is flowing, my dear friends, over here. Okay, this is P region and this is intrinsic and this is a N region, my dear friends. Okay, very important over here. Okay, and this particular region is called what, my dear friends? Absorption region. Okay, and one more important thing is that the region where the electron and hole pairs are generated, okay, due to light. So what is other name? How we can define the absorption region? Absorption region can also be defined, my dear friends, the region where, okay, the region where electron hole pairs are generated due to light, okay, is called absorption layer. Okay, so ఇక్కడ ఏమైతుంది, ఎలక్ట్రాన్ హోల్ పేర్స్ జనరేట్ అవుతుంది. ఎట్లా జనరేట్ అవుతుంది? ఫస్ట్ లైట్ పడుతుంది, ఆ లైట్ మొత్తం ఈ రీజన్ అబ్జర్వ్ చేసుకుంటుంది. దానివల్ల వాట్ ఈస్ హ్యాపెనింగ్, మై డియర్ ఫ్రెండ్స్? Here and there charge carriers are generated, okay, my dear friends. Okay, and width of the depletion region is might spread throughout the semiconductor. It is spreading throughout the semiconductor, my dear friends. Okay, now here the important points you need to remember. What are the points you need to remember means, that is what are the things till now I told, including that what happens, my dear friends. Okay, see here, width of the depletion layer depends on what are the factors or the absorption layer. Okay, first one is width of the depletion layer. DR means depletion layer. Depends upon first one is intensity of the light. Whenever the intensity of the light falls on here, absorption region might spread throughout the sea. Means because of the intensity of light, what happens? Absorption region might spread throughout the device. Throughout the device, my dear students. Second one, very important, my dear friends, material with which the photodiode is made up of. Made up of, my dear friends. Okay, so what happens if I am increasing the current intensity, my dear friends, then photo current increases. IP means photo current, P means photo current. If I am decreasing the intensity, what happens, my dear sir? The photo current will decreases, my dear friends. Okay, the final conclusion is very important, my dear friends. Always when I am comparing the currents, my dear friends, when I'm comparing the currents, always IP means I'm comparing the PN photodiode with PIN photodiode. So always the PN photodiode, the photo current in PIN photodiode is greater than the photo current in, my dear friends, PN photodiode. Means why we are going for the 1 2 next, to increase the current, to increase the photo current. Okay, నేను ఇక్కడ ఇంక్రీజ్ చేయాలనుకుంటున్నాను. సో PIN photodiode లో means what is happening, my dear friends, the current will be more when compared to the photo current is more over here, my dear friends. Okay, very important point you need to remember over here. Here one more important point you have to remember is that it is how many junctions is there. Here it is having a single PN junction features. Okay, and it is a 3-layered semiconductor. Okay, so here see here, it is a single PN junction is there, only one junction, P and N. This is simply an intrinsic region. And how many layers? It is a 3-layer, layer 1, layer 2 and a 3. It is a 3-layer, okay, semiconductors. Here the current is due to drifting of the photo carriers. Okay, so why, how you are getting the photo current? The photo current is getting because of the drifting, because in the drift component is greater than the diffusion component, my dear friends. Okay, these are all the important parameters that you have to remember as far as the PIN photodiode is concerned. Okay, similarly PIN photodiode characteristics, very important, my dear friends. So PIN photodiode characteristics, my dear friends. Okay, very beautiful concept and very interesting and important concept, my dear friends. Okay, listen carefully. Okay, the first one is quantum efficiency. what is quantum efficiency? Okay, so the quantum efficiency, my dear students, very important itself is that see, efficiency can always represented by, okay, represented by eta, my dear students. Okay, always it represented by eta, my dear students. Okay, eta equal to, now what I'm going to do in a photodiode is nothing but the, ఇది ఒక ఫోటో డయోడ్ తీసుకున్నాను అన్న, ఈ ఫోటో డయోడ్ మీద ఏం చేస్తున్నాను, ఈ ఫోటో డయోడ్ మీద what I'm going to do, my dear students, I am projecting the light. When I am projecting the light, my dear students, on this one, and I am going to get the output is what, electron hole pairs. అంటే ఇక్కడ ఏంది, ఇది ఒక ఫోటో డయోడ్ లో నేను ఏం చేశాను, I am projecting the here incident light photons, light incident చేశాను. ఓకే, నా బయటికి ఏమొస్తుంది, ఎలక్ట్రాన్ హోల్ పేర్స్, టైం బట్టి EHP అంటే ఎలక్ట్రాన్ హోల్ పేర్స్ అంటారు, my dear students. Okay, this you are going to get, my dear students. Okay, so quantum efficiency can be, what is the formula, my dear students, is very important. Quantum efficiency equal to, okay, number of electron hole pairs generated per time, my dear students, per time divided by number of incident light photons. Per time, my dear students. Okay, so when I am taking with respect to the number of electron, this is output generated by time, by because of the light only you are getting this one. This is with respect to time, so this is also called EHP generation rate, because with respect to time this can be written as EHP generation rate divided by incident photon rate. Incident photon rate, my dear students. Okay, which is equal to RE divided by RP, my dear students. Okay, which is equal to RE divided by RP, my dear students. Okay, which is equal to RE divided by RP. This is the formula. Now here RE formula, again the formula for RE is IP by, that is photo current by optical power, not IP by Q, sorry, RE equal to IP by Q divided by optical power divided by H into F, that is Planck's constant into frequency. Okay, Planck's constant into frequency, my dear students. Okay, I am writing in the next page again here. This is nothing but this formula itself is this one. For RE, this is the numerator. For RP, it is the denominator, my dear students. Okay, similarly, now see here, the efficiency equal to IP by Q divided by P naught by H frequency. H nu, my dear students. HF is nothing but F is nothing but here frequency. Okay, we are going to take it as a frequency, my dear students. Okay, say here what is the Planck's constant value? Planck's constant equal to 6.634 into 10 power minus 34, my dear students, joule second, my dear students. Okay, then efficiency equal to H nu into IP divided by P naught into Q, my dear students. Okay, see here E is equal to, simply what is the formula? H nu, which is equal to same as H into F. Okay, H into F, my dear students, which both are same only. Okay, nu is nothing but frequency. I have taken here like this, frequency, my dear students. Okay, therefore this is what the efficiency equal to E into IP, my dear students, photo current by optical power into charge of the electron. Okay, IP is what? Photo current. Okay, and Q is the charge of the electron. How much the charge of the electron? Which is equal to 1.6 into 10 power minus 19 coulombs. coulombs, my dear students. Okay, very important over here. Okay, E is equal to H nu, my dear students. Okay, all these things are pretty important over here. Okay, now we can represent some similarly over here. Okay, we can represent as nu equal to this lambda, okay, which is also you can write it as c by velocity of light into lambda. The formula for the frequency is equal to c by lambda, that is velocity of light into divided by wavelength. Okay, this I am going to use in problems. Okay, this is the formula, my dear students, for the calculation of the efficiency. For the calculation of the efficiency, my dear students. Calculation of the efficiency, my dear students. Okay, very important parameter. Just I would like to bring it to your notice. Okay, similarly, this is the first characteristic, my dear students. Okay, next characteristic is what? Responsivity. What is responsivity? Responsivity equal to or equal to IP by P naught. IP by P naught, my dear students. Okay, IP by P naught is the responsivity. So always here, what is the formula? Now take the efficiency formula. Efficiency is equal to what kind of thing you are getting is that E into IP divided by P naught into Q, my dear students. Okay, then the efficiency equal to IP by P naught is nothing but R into E by Q. E by Q, my dear students. Okay, this is the next, my dear students, which I have depicted over here, my dear students, in a detailed manner. Okay, similarly, next parameter is dark current. Responsivity is over. Next one is the dark current, my dear students. What is dark current? Okay, the current in the PN junction. I told you in the yesterday's class only. PN junction diode in the absence of the light. Okay, the current that you are going to get over here. Okay, the current in the PIN diode, my dear students, in the absence of what, my dear students? In the absence of what? Light. Like which I told you where, my dear students? I told you where? I told you in LDR. ఎల్డిఆర్లో చెప్పాను కదా ఆల్మోస్ట్ ఆల్. ఓకే, దెన్ వాట్ హ్యాపెన్స్? జనరల్గా లైట్ ప్రొజెక్ట్ చేస్తే లైట్ డిపెండెంట్ రెసిస్టర్ మీద మనం లైట్ ప్రొజెక్ట్ చేస్తే ఏమైంది? రెసిస్టెన్స్ తగ్గుతుంది. ఓకే, ఏదైనా ఒక ఎల్డిఆర్ తీసుకుంటే, ఇదొక ఎల్డిఆర్ తీసుకుంటే లైట్ ప్రొజెక్ట్ చేస్తే రెసిస్టెన్స్ అనేది మీకు ఏమవుతుంది? తగ్గుతుంది. నేను రెసిస్టెన్స్ పెంచాలంటే ఈ లైట్ ఉన్న రీజన్ నుంచి ఎల్డిఆర్ని నో లైట్ రీజన్ తీసుకెళ్ళాలి. అప్పుడు ఏమైంది, మై డియర్ స్టూడెంట్స్? సారీ, రెసిస్టెన్స్ అనేది పెరుగుద్ది. ఓకే, ఆ కరెంట్ ఏమంటారంటే డార్క్ కరెంట్. ఓకే, మీన్స్ ద కరెంట్, మై డియర్ స్టూడెంట్స్, ద కరెంట్ ఇన్ PN diode in the absence of optical light. In the absence of the optical light, my dear friends, PIN photodiode. See, this is PIN photodiode. In the absence of what, my dear friends? In the absence of the optical light. Okay, which is called dark current. Dark current, it is same as what, my dear friends? It is same as reverse saturation current represented by I naught. It is same as the reverse saturation current, my dear students. Okay, and this particular current, okay, I naught, my dear friends, this is nano amperes per silicon and micro amperes for germanium. Micro amperes for germanium, my dear students. Okay, this is one more important point you need to remember over here, my dear students. Okay, very important point. Okay, similarly, next characteristic, spectral response. Spectral response, my dear students. Okay, see here, the PN photodiode is responding for certain range of wavelengths. Okay, so here what is spectral response means? The range of wavelengths. The range of wavelengths for which photodiode response. Photodiode response is called what, my dear students? It is called spectral response. చాలా సందర్భాల్లో చెప్పాను అలా, వెరీ వెరీ ఇంపార్టెంట్. జనరల్గా ఎలా ఉండాలి, ఎలక్ట్రాన్ హోల్ పేర్ జనరేట్ చేయాలంటే ఫోటోడయోడ్లో ఆల్వేస్ ఇన్సిడెంట్ ఎనర్జీ ఈజ్ ఆల్వేస్ గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు బ్యాండ్ గ్యాప్ ఆఫ్ ద సెమీకండక్టర్. ఇది ఎప్పుడు మనకి దెన్ ఓన్లీ వాట్ హ్యాపెన్స్, ఈహెచ్బి జనరేషన్ టేక్స్ ప్లేస్, ఎలక్ట్రాన్ హోల్ పేర్ జనరేషన్ టేక్స్ ప్లేస్. ఇది ఆల్రెడీ చెప్పాను, ఇప్పుడు చాలాసార్లు చెప్పాను. టేక్స్ ప్లేస్ మై డియర్ ఫ్రెండ్స్, takes place, my dear students. Okay, very very important point you need to remember over here. అదే మీకు ఇంకోటి చెప్పాను, మీరు వేవ్ లెంత్ క్యాలిక్యులేట్ చేయాలంటే మ్యాక్సిమం వేవ్ లెంత్ ఓకే 1.242 బై ఎనర్జీ ఎలక్ట్రాన్ వోల్ట్స్లో ఇచ్చినప్పుడు మై డియర్ స్టూడెంట్స్ దిస్ విల్ బి మైక్రోమీటర్స్. వేవ్ లెంత్ దేంట్లో వస్తుందనా, మైక్రోమీటర్స్లో. ఇది చెప్పాను ఫార్ములా. అదే మీకు వేవ్ లెంత్ మై డియర్ స్టూడెంట్స్ ఇన్ యాంగ్స్ట్రామ్స్లో కావాలంటే 12,420 divided by energy in electron volts. Angstroms la kavalante my dear students. Okay, if you want to get in the angstroms my dear students, okay, very very important parameter you need to remember over here my dear students. Okay, similarly with that we are completed about this particular parameter my dear students. Okay, the very very important parameter. Okay, similarly now my dear friends, there is a question that has been asked in the previous paper based upon this one my dear friends. Listen carefully about this particular question over here. Okay, he has given the the concept over here. The a PIN photodiode is constructed of gallium arsenide which has a band gap of 1.43 electron volts. Find the maximum wavelength that can generate the current, my dear students. Okay, this is nothing but energy. He only given that the energy itself is how much my dear students. He has given the energy is how much my dear students. Energy band gap is 1.43 electron volts. Okay, and here this is what he has given my dear students. Okay, maximum wavelength. Okay, in what my dear students, he has given the 4 options. By seeing the options we can check it whether the answers will be given my dear students whether the answer will be given where my dear students. Okay, he has given the first one is 0.761 micrometers. Okay, he has given all the answers in micrometers. 0.867 micrometers, 0.467 micrometers, 0.367 micrometers, my dear friends. Okay, he has given these particular options over here. Then what happens, the lambda max equal to 1.24 divided by energy gap. Okay, that is equal to 1.24 divided by 1.43, my dear students. Okay, then you are getting 0.867 micrometers lambda max, my dear students. Okay, you are going to get the lambda max value is this one. This is the value you are getting my dear students. Okay, in that way we are going to solve the problems based upon this particular photodiode. Okay, similarly next photodiode, one more important question my dear students. Okay, in a 100 nanoseconds He has given, my dear friends, 100 nanoseconds he has given. Okay, pulse. Okay, it is a 100 nanoseconds pulse. The photons that are generated is 6 into 10 power 6 photons. Okay, at a wavelength of 1300 nanometers, falls on a gallium arsenide PN photodiode, an average of, okay, 5.4 into 10 power 6 electron hole pairs are generated. Calculate the quantum efficiency. Calculate the quantum efficiency, my dear friends. Okay, he has given the 4 options. Okay, he has given the 4 options, my dear friends. Option A, B, C and D, 90%, 80%, 60%, 70%, my dear friends. Okay, 4 options he has given. So efficiency equal to E, that is EHP generation rate by incident photon rate. Okay, see here, this is what, my dear friends, 100 nanoseconds pulse. This is the photons. Okay, see here, this is photons. Okay, that are generating. This is what, my dear friends, denominator. This is what, RP, and this is what, my dear friends, average electron hole pairs, RE. Therefore, efficiency is equal to what we are getting, my dear friends, 5.4 into 10 power 6 divided by into 100. You are getting these values how much? 90%, my dear friends. You are getting these particular values 90%, my dear friends. Okay, is that clear up to here, everyone? Similarly, photons are incident on a PIN photodiode, has a responsivity 0.65, okay, ampere per watt, my dear friends. If the optical power incident is, my dear friends, whatever the optical power incident is, 10 power microwatts, this is 10 microwatts. Okay, calculate the photocurrent generated, my dear friends. Okay, calculate the photocurrent generated. He has given the responsivity, my dear friends. This is R, and the optical power, this is what, my dear friends, this is P naught. Okay, then what is responsivity? Responsivity equal to IP by P naught. Okay, now he is asking the photocurrent. What is, he is asking IP. What is IP, my dear friends? Okay, therefore IP equal to R into P naught. Okay, R into P naught. Okay, then what is the value, my dear friends? The value of R is this one, 0.65. Then this one is 6.5 microamperes. Is it right, my dear friends? This is what, 6.5 microamperes, my dear friends. Okay, like that you are going to get these particular parameters over here, my dear friends. Okay, very, very important one. Okay, similarly, completed, everyone? Next one. This question, after completion of this question, my dear students, listen. This is a PIN photo detector. A PIN photo detector, okay, has a junction capacitance of 16 picofarads, active area of 10 millimeter square, okay, and a responsivity of 0.5 ampere per watt. It is illuminated by a light of intensity. This is 1 milliwatt per centimeter square. A voltage output is obtained by connecting a 100 kilo ohms load resistor RL in series with the detector. In series with the detector, the steady state voltage across RL, the steady state voltage across the load resistance. Okay, the steady state voltage across this particular load resistance is asking, my dear students, over here. Okay, he has given the parameters. First write down the parameters what he has given, all the particular parameters, my dear students. Then we are going to do this particular problem in a detailed manner. Okay, what kind of parameters he has given, first check it over here. Very important parameters. Okay, first one is junction capacitance Cj. This is Cj equal to 16 picofarads. Okay, and active area A equal to, this is what, 10 millimeter square, my dear students. Responsivity R, this is what, the responsivity, my dear students, you only given R equal to 0.5 ampere per watt. Okay, and the intensity of the light I equal to, my dear students, 1 milliwatt per centimeter square. 1 milliwatt per, intensity is always power by area. This is P by A. Power is 1 milliwatt by area, centimeter square, my dear students, you only given. And the load resistance RL equal to 100 kilo ohms. Now he is asking what is the steady state output voltage. This is asking, my dear students. Okay, now how to do this particular problem means, first I told you that the responsivity equal to what, my dear students, IP by P naught, IP by P naught. Okay, but I want to get the voltage across the load resistor. Voltage across the load resistor formula VL equal to, my dear students, IP into RL. Okay, but RL is there, IP is not there. To calculate this particular voltage, in order to calculate this particular voltage, IP is not there, RL is there. So I want to find out the IP, my dear students. Okay, IP equal to, here intensity equal to, what is the formula? Okay, optical power, this is the optical power. Okay, and here what happens, he has given, this is intensity, my dear students. Okay, then I am going to take it IP equal to, again, okay, very important one, you need to take it over here, area into, that is current. Okay, this is what, okay, here IP by P naught. From this IP equal to R into power, P naught, my dear students. Okay, but what is P naught? It is nothing but the P naught. I equal to what, my dear students? Optical power by A. Okay, then P naught equal to, what is the formula? A into I, my dear students. Now substitute this formula. Therefore, IP equal to R into P naught equal to A into I. A into I, my dear students. Okay, then we can take the responsivity values, my dear students, and represent over here. Now, responsivity. Responsivity, my dear students. Okay, responsivity equal to 0.5 ampere per watt into, my dear students, again area. Area how much is given? This is 10 millimeter square into, my dear students, intensity. This is intensity, my dear students. He has given the intensity is equal to 1 milliwatt per centimeter square. Okay, then what kind of value you are going to get, my dear students? See here, we need to convert and do all the parameters, my dear students. Then you are getting the value of IP equal to, finally, IP you are going to get is 5 into 10 power minus 5 amperes. 5 into 10 power minus 5 amperes is IP, my dear students. Okay, then amperes, my dear students. Then what is voltage? Voltage equal to IP into RL. Okay, what is this one? 5 into 10 power minus 5, my dear students. And RL, what is the value of RL he has given? The RL value he only given is 100 kilo ohms. Okay, 100 kilo ohms, my dear students. Now substitute by this one is 100 into kilo is 10 power cube. Then voltage is equal to how much you are getting? 5 volts, my dear students. Okay, you are going to get the voltage is how much, my dear students? 5 volts. Okay, very very important parameters. Just I would like to bring it to your notice, my dear students, over here. Okay, similarly, is that clear? Okay. Next diode is very very important diode, and the final diode and the diode characteristics, and that particular one is called avalanche photodiode. Avalanche photodiode. It is also called APD. It is also called APD. Avalanche photodiode. It is also called APD, my dear students. Okay, APD, avalanche photodiode. How is this one is there? Just listen carefully. How many layers are there for this particular diode? This is always the photodiodes are operating in reverse bias, my dear students, as I told you. But LEDs are always in forward bias, emitting. This is detection. That's the reason. How many layers are there? Okay, it consists of the 4 layers. Layer 1, layer 2, layer 3 and layer 4, my dears. 4 layers are there over here. Okay, and this one itself is layer 1. This one is layer 2. This one is layer 3. This one itself is layer 4, my dear students. Okay, layer 4. Okay, and here what ultimately I am going to tell you, this particular layer is called N layer, N plus layer. This one itself is called P plus layer. Okay, this one is P layer, my dear students. Listen carefully. And this is the intrinsic layer, my dear students. Okay, intrinsic layer, my dear students. Okay, so here a junction is called, and that junction is called PN junction. How many layers are there? 4 layers. So it is called what, my dear students? This is a 4-layered semiconductor. 4-layered semiconductor, my dear students. Okay, 4 layered semiconductor, my dear friends, and the layered descriptions also I am going to tell you one by one. Okay, so here what happens, this is very important diode, my dear friends. Okay, so the points I need to tell you over here itself is very important. Okay, so layer descriptions, see avalanche photodiode layer descriptions, listen here, very important. How many layers are there? 4 layers are there. Okay, so layer descriptions are layer 1. Layer 1 is, this is heavily doped, my dear friends. Okay, the first layer is called N plus, is nothing but a heavily doped layer 1, N plus, which is equal to heavily doped my dear friends, thin N plus layer, thin N plus layer, my dear friends. Okay, layer 2 equal to, my dear friends, layer 2. This is P layer, my dear. Layer 2 is P layer, and this particular layer is called normally doped thin P layer. Third one, layer 3. What is layer 3, my dear friends? Okay, layer 3. This is intrinsic layer, my dear friends. Very lightly doped. This is I minus minus, like this, my dear friends. Okay, very lightly doped. Intrinsic layer. Very lightly doped intrinsic layer. And fourth layer, my dear friends, P plus layer. This is also heavily doped, thin. Same as, very important, my dear friends. Okay, same as, my dear friends, this is what, heavily doped thin P plus layer. P plus layer. These are all the important layers that you need to remember, my dear friends. Okay, you need to remember all these particular layers, my dear friends. Okay, very important over here. Okay, now see, now I am going for the layer descriptions. Okay, which I told you. Similarly, avalanche photodiode. Okay, how the working takes place. Okay, how the working takes place, my dear friends, very important. Okay, see here, generally a junction is formed here in between, and this junction is called PN junction. PN junction, my dear friends. Okay, now see here what happens, more amount of the light is falling on here, layer 3. Layer 3, more amount of the light is following over here, my dear friends. Then what happens here, the holes and electrons, they were going to recombine, my dear friends. Okay, so holes and electrons are going to recombine over here, and more number of, here what happens, electron and hole pairs are generated. Okay, more number of, here maximum what happens means more number of electrons and holes are generated. So ఇక్కడ ఏమైతున్నా ఈ ఎలక్ట్రాన్స్ ఏవైతే ఇక్కడ జనరేట్ అవుతాయో, ఓకే, ఈ ఎలక్ట్రాన్స్ దీస్ ఆర్ ఎంటరింగ్ ఇన్ టు ద పీ రీజియన్. పీ రీజియన్స్లో ఏముంటాయి, హోల్స్ ఉంటాయి. ఓకే, సో అందుకే ఇక్కడ మనకేంది అవలాంచి మల్టిప్లికేషన్ అంటే గెయిన్ ఎక్కువ జరుగుద్ది. అంటే జనరల్గా ఎలా ఉంటుందంటే, మీరు ఎలక్ట్రిక్ ఫీల్డ్ ఇలా తీసుకున్నప్పుడు, లిసన్ కేర్ఫుల్లీ మై డియర్ స్టూడెంట్స్. ఓకే, మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఏమైంది ఇక్కడ, దిస్ ఈజ్ వాట్, ఇక్కడ తీసుకుంటే సిఇఆర్ మనకేమవుతుంది అంటే ఈ యాక్సిస్, ఇది ఎలక్ట్రిక్ ఫీల్డ్ యాక్సిస్ తీసుకుంటే, మై డియర్ స్టూడెంట్స్. ఓకే, జనరల్గా అబ్జార్ప్షన్ రీజన్ అంటే ఇక్కడ ఉంటుంది. దిస్ ఈజ్ అబ్జార్ప్షన్ రీజన్. దిస్ ఈజ్ అబ్జార్ప్షన్ రీజన్, మై డియర్ ఫ్రెండ్స్. ఓకే, ఇది అబ్జార్ప్షన్ రీజన్. అయితే దీనివల్ల ఏంది, పిఐఎన్ డయోడే. ఇది పి అండ్ ఐఎన్ అంటే నాకేంది నాకు కావాల్సింది ఏంది, మై డియర్ ఫ్రెండ్స్, నాకు పిఐఎన్ ఫోటో డయోడ్ కంటే ఏపీఎన్ అవలాంచి ఫోటో డయోడ్లో కరెంట్ ఎక్కువ చూపించాలి. ఇంతకుముందు ఏం చూపించాను, పిఎన్ ఫోటో డయోడ్లో నుంచి కంటే పిఐఎన్ ఫోటో డయోడ్లో కరెంట్ ఎక్కువ చూపించాను. ఇక్కడ ఏం చేస్తాను, పిఐఎన్ ఫోటో డయోడ్ కంటే అవలాంచిలో ఎక్కువ పవర్ చూపించాలి, ఫోటాన్ కరెంట్. ఓకే, దాని గురించే ఈ ఎక్స్ట్రా లేయర్ యాడ్ చేశాను. ఈ ఎక్స్ట్రా లేయర్ యాడ్ చేయడం వల్ల దీని ఏమంటారు, గెయిన్ రీజన్ అంటారు. అంటే మీకు ఎలా ఉంటాయి నా క్యారెక్టరిస్టిక్స్ అంటే, లిజన్ కేర్ఫుల్లీ, ఇక్కడికి వచ్చేసరికి యు ఆర్ రిప్రజెంటింగ్ ద క్యారెక్టర్స్ ఇన్ సచ్ ఎ ఫ్యాషన్. ఇలా యు ఆర్ రిప్రజెంటింగ్ మై డియర్ స్టూడెంట్స్. ఇలా వస్తుంది. ఓకే, ఇది ఈ రీజియన్ మై డియర్ స్టూడెంట్స్ తక్కువ ఎలక్ట్రిక్ ఫీల్డ్లో కూడా ఇక్కడ ఇది గెయిన్ రీజియన్. దిస్ ఈజ్ వాట్ మై డియర్ స్టూడెంట్స్, దిస్ ఈజ్ గెయిన్ రీజియన్. అంటే జనరల్గా మోర్ అమౌంట్ ఆఫ్ లైట్ ఇక్కడ ప్రాసెస్ చేస్తే ఓకే, ఇక్కడ ఏమైంది, ఇది అబ్జార్ప్షన్ రీజియన్. ఈ రీజియన్ ఇక్కడ ఏమవుతుంది, అబ్జార్ప్షన్ రీజియన్ మై డియర్ స్టూడెంట్స్. ఓకే, ఈ అబ్జార్ప్షన్ రీజియన్ వల్ల వాట్ హ్యాపెన్స్, ఎలక్ట్రాన్ అండ్ హోల్ పేర్స్ ఆర్ జనరేటెడ్. ఓకే, ఇవన్నీ ఎలక్ట్రాన్ అండ్ హోల్ పేర్ జనరేట్ అయిపోయి మై డియర్ స్టూడెంట్స్ ఇంటర్న్ ఇక్కడికి వస్తాయి. ఇక్కడికి వల్ల ఏమవుతుంది, ఇంకా ఫోటో కరెంట్ ఎక్కువైద్ది ఈ పీ లేయర్. అందుకే ఈ లేయర్ 2 ఏమంటారు అంటే మల్టిప్లికేషన్ లేయర్ అంటారు. ఈ లేయర్ని ఇక్కడ ఏమైతే మీకు గెయిన్ రీజియన్, ఇక్కడ గెయిన్ పెరిగింది, గెయిన్ రీజియన్ మై డియర్ స్టూడెంట్స్. దిస్ రీజియన్ ఈస్ కాల్డ్ ద గెయిన్ రీజియన్ మై డియర్ స్టూడెంట్స్. ఓకే, అండ్ దిస్ ఈజ్ ద ఎలక్ట్రిక్ ఫీల్డ్ యాక్సిస్లో ఇది ఈ మీన్ అంటారు, అంటే మినిమం ఎలక్ట్రిక్ ఫీల్డ్ అంటారు. మినిమం తక్కువ ఎలక్ట్రిక్ ఫీల్డ్లో ఇంపాక్ట్ జరుగుద్ది. మినిమం ఎలక్ట్రిక్ ఫీల్డ్ ఫర్ ద ఇంపాక్ట్ అయనైజేషన్. ఓకే, అంటే ఈ యొక్క రీజియన్ గెయిన్ రీజియన్ ఇంకో పేరు ఏంటన్నా వీఆర్ గోయింగ్ టు కాల్ ఇట్ అంటే ఎవలాంచి రీజియన్ అనొచ్చు. ఎవలాంచి రీజియన్ మై డియర్ స్టూడెంట్స్, వీఆర్ గోయింగ్ టు కాల్ ఇట్ యాజ్ ఏ ఎవలాంచి రీజియన్. avalanche region my dear students, avalanche region my dear students. Okay, ఇది load resistance as usual RL. సో కంటిన్యూస్గా ఇక్కడ వచ్చే కరెంట్ ఏంటంటే IP మై డియర్ స్టూడెంట్స్. అంటే ఇక్కడ మీకు గుర్తుపెట్టుకోవాల్సింది ఒకటే ఒక పాయింట్ మై డియర్ స్టూడెంట్స్. ఓకే, ఏంటంటే ఈ యొక్క లేయర్ వల్ల ఇంకా కరెంట్ అనేది ఫోటో కరెంట్ అనేది పెరిగింది my dear students. Okay, the photo current itself is it is going to be increasing my dear students. Okay, so మనకి ఈ యొక్క కంప్లీట్ అవలాంచ్ ఫోటో డయోడ్లో మనం ఏమేమి పారామీటర్స్ తెలుసుకున్నాం అనేది ఐఎమ్ గోయింగ్ టు రైట్ డౌన్ వన్ బై వన్ వేర్ మై డియర్ స్టూడెంట్స్ ఇన్ ద నెక్స్ట్ పేజ్. వెరీ వెరీ ఇంపార్టెంట్ మై డియర్ స్టూడెంట్స్. ఓకే, సో ఇక్కడ ఏమవుతుంది, దీనివల్ల ఈ యొక్క లేయర్ వల్లనే మనకి మల్టిప్లికేషన్ వస్తుంది. ఓకే, అవలాంచ్ మల్టిప్లికేషన్ ఆర్ ఇంపాక్ట్. ఓకే, ఇంపాక్ట్ అంటే ఒక అంటే ఎలక్ట్రాన్స్ ఇన్ పీ లేయర్, ఈ లేయర్ నుంచి 1 కాస్త 2 ఇస్తుంది, 2 కాస్త ఇక్కడ ఏం జరుగుతుంది అనేది నేను మీకు నెక్స్ట్ చూపిస్తాను. ఓకే, సిమిలర్లీ now see here my dear students, it is a 4 layered semiconductor. 4 layered semiconductor లో my dear friends. ఓకే, ఫస్ట్ ఇంపార్టెంట్ ఏంటంటే నేను చెప్పాను కదా, ఇది ఏంటన్నా 4 layered semiconductor avalanche photodiode semiconductor, and the photo current my dear friends, okay, in avalanche photodiode, okay, is greater than the photo current in PIN photodiode my dear students. Is important, which is greater than the photo current in PN photodiode. PN photodiode my dear students. Okay, PN photodiode my dear students. Okay my dear students. Okay, advantages asalu ఏంది ఫీచర్స్ అంటే APD features, very very important. Avalanche photodiode features my dear students. Okay, so it provides high sensitivity. Sensitivity is very good. High sensitivity compared to previous, compared to PIN photodiode. Okay, idilana. Okay, similarly speed of response ekva, high speed of response. Okay, it has internal gain mechanism. It has a gain mechanism ఎక్కడ ఉంది, పీ లేయర్లో మై డియర్ స్టూడెంట్స్. ఓకే, జంక్షన్ మాత్రం ఒకటే ఉంది నాన్న, గెయిన్ మెకానిజం ఏమో ఎక్కడ ఇగో ఇది గెయిన్ మెకానిజం ఈ లేయర్లో. ఓకే, అండ్ సింగిల్ పిఎన్ జంక్షన్, ఇది కూడా చెప్పాను కదా. single PN junction. సింగిల్ పిఎన్ జంక్షన్ మై డియర్ స్టూడెంట్స్. ఓకే, కండక్టివిటీ పెంచాలి కాబట్టి, ఇక్కడ ఫోటాన్ కరెంట్ పెంచాలి కాబట్టి మై డియర్ స్టూడెంట్స్ ఎప్పుడైనా కూడా ఈ లేయర్ 1 యొక్క ఈ లేయర్ 4 అనేది ఎప్పుడు ఏం చేస్తామంటే ఎక్కువ డోప్ చేస్తాం, హెవీలీ డోప్ చేస్తాం. ఓకే, ఫోటాన్ కరెంట్ పెంచాలి కాబట్టి. ఓకే మై డియర్ స్టూడెంట్స్, ఓకే దిస్ ఈజ్ వాట్ టు ఇంక్రీజ్ ద కండక్టివిటీ. To increase the conductivity, P and N are heavily doped. P and N are heavily doped, my dear students. ఓకే, అయితే దీనివల్ల ఏమవుతుందంటే ఇక్కడ ఇంకో పాయింట్, నేను ఆన్ ద అప్లికేషన్ ఆఫ్ దిస్ పర్టికులర్ రివర్స్ బయాస్, ఈ రివర్స్ బయాస్ అప్లై చేశాను కాబట్టి ఈ డిప్లీషన్ లేయర్కి ఎక్కడ పోతుంది, మూవ్స్ అప్ టు హియర్, ఇక్కడ మూవ్స్ అప్ టు హియర్ అప్ టు P ప్లస్ ఇలా మూవ్ అవుతుంది. డిప్లీషన్ లేయర్ అనేది దిస్ సైడ్ కూడా ఇలా మూవ్ అవుతుంది అనమాట. ఓకే, అప్ టు హియర్. ఓకే, హియర్ దట్ ఈస్ అనదర్ పాయింట్. నౌ ఇక్కడ ఏం జరుగుతుంది, ఇక్కడ ఏం జరుగుతుంది, అవలాంచ్ మల్టిప్లికేషన్ జరుగుతుంది. హౌ ఇట్ ఈస్ టేకింగ్ ప్లేస్. ఒక ఎలక్ట్రాన్స్ ఏ లేయర్లో, పీ లేయర్లో మై డియర్ స్టూడెంట్స్, ఇక్కడి నుంచి ఇట్ గివ్స్ రైజ్ టు ఒకటి, అగైన్ రెండు ఇస్తుంది, అగైన్ రెండు కాస్త అగైన్ మై డియర్ స్టూడెంట్స్ ఇట్ ఈస్ గివింగ్ రైజ్ టు. ఓకే, అండ్ ఒక ఎలక్ట్రాన్ సిగ్నేచర్ ఎలా నెగిటివ్ గివ్స్ రైజ్ టు అగైన్ దిస్ ఎలక్ట్రాన్ and this electron. Okay, ఇది మళ్ళీ ఒరిజినల్, ఇట్ ఈస్ కంబైనింగ్ విత్ ఆటమ్, ఇది కంబైనింగ్ విత్ అగైన్ ఇట్ గివ్స్ రైజ్ టు ఇలా 2 electrons ఇలా. ఓకే, అగైన్ దిస్ ఈజ్ వాట్ ద లిబరేషన్, అగైన్ ఇవి మళ్ళీ ఆటమ్స్తో కొలైడ్ అవుతాయి. ఓకే, ఇలా అంటే 1 is gives rise to 2, 2 gives rise to 4, 4 gives rise to 8, like that. And this process of collision is called, ఈ process of collision ఏమంటారు, impact collision. Impact collision, my dear students. Impact collision, my dear students. Okay, this process of okay collision is called impact collision, my dear students. Okay, is that clear, my dear students, up to here everyone? Okay, what is layer 2? Layer 2 is called what? Multiplication layer. Okay, layer 2 is what, my dear students? This amplification of electrons. Okay, ఇక్కడ ఏమైనా పెరుగుతున్నాయి అంటే దీని ఏమంటాము, this amplification of electrons is called, this amplification of electrons is called avalanche multiplication. Avalanche multiplication. Where the avalanche multiplication takes place? Layer 2. Layer 2, which is called P. It is also called multiplication layer. All these points you need to remember, my dear students. Okay, very very important parameters. Okay, so here this is also, so this what I am going to tell you, my dear students. Okay, so inka carriers increase ayanukondi, ఇంకా క్యారియర్స్ ఇంక్రీజ్ అయితే ఏమవుతుంది, వాట్ హ్యాపెన్స్, ఫోటో కరెంట్ పెరుగుద్ది, దానివల్ల ఏమైంది, బ్రేక్ డౌన్ జరుగుద్ది, అప్పుడు జీనర్ డయోడ్కి వెళ్తాం. వీఆర్ గోయింగ్ ఫర్ ద జీనర్ డయోడ్, మై డియర్ స్టూడెంట్స్. ఓకే, దట్స్ ద రీజన్ ఆఫ్టర్ కంప్లీషన్ ఆఫ్ దిస్ పర్టికులర్ వన్ ఐఎమ్ గోయింగ్ ఫర్ దట్ పర్టికులర్ డయోడ్, మై డియర్ స్టూడెంట్స్. ఓకే, వెరీ వెరీ ఇంపార్టెంట్ పాయింట్ దట్ ఐ వుడ్ లైక్ టు బ్రింగ్ ఇట్ యువర్ నోటీస్. ఓకే, సిమిలర్లీ avalanche photodiode parameters. First one, multiplication factor. multiplication factor, my dear students. Okay, here also what are the characteristics we have been studied. Okay, like PIN photodiode, we need to study the characteristics over here. Okay, M multiplication factor దేంతో రిప్రజెంట్ చేస్తామంటే క్యాపిటల్ M తో రిప్రజెంట్ చేస్తాం. M equal to, my dear students, which is equal to IM by IP. IM అంటే ఏంటంటే మల్టిప్లైడ్ ఫోటో కరెంట్. divided by primary photocurrent. Primary photocurrent. అయితే మన బిఫోర్ అవలాంచి మల్టిప్లికేషన్. ఓకే, ఐపి అంటే చూడండి ఫోటో కరెంట్ బిఫోర్ అవలాంచి మల్టిప్లికేషన్ ముందు దాన్ని ఏమంటారు? ఐపి అంటారు, మల్టిప్లికేషన్ ముందు. అయితే ఐపి ఫోటో కరెంట్ ఆఫ్టర్ అవలాంచి మల్టిప్లికేషన్కి ఏమంటారు అంటే ఐఎం అంటారు, మై డియర్ స్టూడెంట్స్, విచ్ ఈజ్ ఈక్వల్ టు ఐఎం. అంటే బిఫోర్ ఐపిఏ బట్ ఆఫ్టర్ మల్టిప్లికేషన్ జరుగుతుంది కదా, దట్ ఈజ్ అవలాంచి మల్టిప్లికేషన్ జరుగుతుంది కాబట్టి దాన్ని ఏమంటారు? ఐఎం అంటారు, మై డియర్ స్టూడెంట్స్. ఓకే, వెరీ వెరీ ఇంపార్టెంట్ ఓవర్ హియర్. ఓకే, ఎం ఈజ్ ఈక్వల్ టు దిస్ పర్టికులర్ ఫార్ములా. Again here the responsitivity, the formula for the responsitivity, very very important, of avalanche photodiode is always the responsitivity in avalanche photodiode is equal to M times, my dear students, the responsitivity of the PIN photodiode. PIN photodiode, my dear students. Responsivity of the PIN photodiode, my dear students. Okay, very very point you have to remember over here when it comes into the responsivity, my dear students. Okay, similarly, okay, like that we need to do over here the parameters, my dear students. Okay, Usha, water. Okay, similarly, with that we are completed about the concepts based upon this particular one, my dear students. Okay, now we are going for the very very important problem, my dear students, based upon this one. Okay, see here, the question itself is very very important, my dear students. Okay, the important problem we need to do over here. A silicon avalanche photodiode has a quantum efficiency of 0.65 at a wavelength of 900 nanometers. Okay, and suppose okay 0.5 microwatts. Okay, microwatts. Okay, microwatts, this is not there, my dear students, already it is repeated. Suppose 0.5 microwatts of the optical power produces a multiplied current of 10 microamperes. Find the multiplication factor. He is asking what is the multiplication factor, my dear students. He is asking. Okay, very very important, my dear students, over here. Okay, similarly, see your efficiency. .65 is the efficiency, and lambda wavelength equal to 900 nanometers, my dear students. Okay, and optical power P0 equal to power equal to 0.5. He has given where here 0.5 microwatts, my dear friends. And he is asking one more important parameters. What is IM? He has given a multiplied photocurrent IM he has given, which is equal to 10 microamperes. My dear friends, he only given 10 microamperes, my dear friends. Okay, so all these particular one things that he has given, my dear friends. Okay, and now he wants to find out what, my dear friends, multiplication factor is asking. Multiplication factor means you need to get IM by IP, but IM is there but IP is not there. So first to find out IP, first to find out IM is there. To find out the multiplication factor, IM by IP, but IM is there, IP is not there, my dear students. Okay, then what I'm going to do, my dear students, is very, very important over here. Okay, then P naught and IM, my dear students. Okay, then to find out this particular one is very, very important. The efficiency formula, I told you, the efficiency equal to E into IP, my dear students, divided by P naught into Q. Okay, but what is E is equal to H in U. H in U into IP divided by P naught into Q. But what is nu? Nu equal to C by lambda. H into C into IP divided by, okay, lambda. Okay, lambda is always, we are going to take it as a lambda parameter, lambda into P naught into Q. Lambda into P naught into Q, my dear friends. Okay, these are all the parameters. Just we have to know over here. Okay, nu బదులు C by lambda రాసుకున్నాం. దీంట్లో నుంచి మీకు IP వస్తుంది, IP వస్తుంది. అన్ని పారామీటర్స్ ఉన్నాయి కదా, సబ్స్టిట్యూట్ చేయండి ఈ ఫార్ములాలో. ఇక్కడ అండ్ ఇక్కడ, మై డియర్ ఫ్రెండ్స్, n ఈక్వల్ టు 0.65, my dear friends, which is equal to H value 6.634 into 10 power minus 34. Okay, velocity of light 3 into 10 power 8, okay, into IP divided by lambda. What is lambda? 900 into 10 power minus 9 into lambda is over P naught value, you only given, this is 0.5 into 10 power minus 6, okay, into charge of the electron, this is 1.6 into 10 power minus 19, my dear friends. Then you are getting this IP value. Okay, you are getting the IP value, my dear students. Okay, how much IP value you are going to get is also very, very important over here. Okay, and IP equal to 0.23 into 10 power minus 6, you are getting, my dear students, amperes. And he has given the IM value. IM value he only given, my dear students, approximately 10 microamperes he has given. Multiplication factor equal to IM by IP. IM by IP, my dear students, that is 10 into 10 power minus 6 divided by 0.23, my dear students, into 10 power minus 6. Okay, then you are getting this will get cancelled out, my dear, 1000 divided by 23. How much, my dear students, you are getting? The answer is approximately 43, I think. Okay, 43, my dear students, this is the exact answer. All these questions has been asked under the previous papers, my dear students. Okay, all these things has been asked under the previous papers, my dear students. Okay, similarly, is that clear, my dear students, up to here, everyone? Is that clear? Is that clear, my dear friends? Usha? Textbook. Is that clear, my dear friends? Up to here, everyone? Okay. With that, we had completed about this particular concept over here, my dear friends. Okay. Similarly, we are going for the next concept, my dear friends. Very, very important one. Very, very important one, my dear friends. Over here. Next one is Zener Diode. Zener Diode, my dear friends. Okay, very, very important concept. Next one is Zener Diode, my dear friends. Okay, so what is this diode? Why we are going for this particular diode, my dear friends? We are going to study about this particular one in a detailed manner, my dear friends. Okay, Zener Diode. How we can operate the Zener Diode, my dear friends? In which way we are going to operate the Zener Diode? What is the working principle of the Zener Diode? Okay, Zener Diode, I told you, my dear friends, always it is again very, very important. The Zener Diode always operating in the what, my dear friends? In what? Reverse bias. Okay, and Zener Diode itself is okay, we are going to call it as a Z diode also. Zener Diode, my dear friends, it is a silicon PN junction semiconductor device. Okay, it is a silicon PN junction semiconductor device. Semiconductor device always operated in what, my dear friends? It is operated in reverse breakdown region. Always it is operating in a reverse breakdown region. Reverse breakdown region, my dear friends. Okay, always we are going to operate in what, my dear friends? In reverse breakdown region. Reverse breakdown region, my dear friends. Reverse breakdown region, my dear friends. Okay, very, very important one here. Generally, always what I'm going to tell you itself is that a Zener breakdown, okay, or a Zener diode is a silicon PN junction silicon, that is a semiconductor diode, my dear friends, which is operated in always reverse breakdown region. Always in the reverse breakdown region, my dear friends. Okay, and Zener diodes, okay, always fabricated with the precise breakdown voltages. Okay, very, very important, my dear friends. The second point itself is that always Zener diodes, my dear friends, are fabricated with always fabricated with precise breakdown voltages. Precise breakdown voltages by controlling the doping level during manufacturing. Okay, by controlling doping level during manufacturing. During manufacturing, my dear friends, listen carefully. During manufacturing, So what I am going to tell you, my dear friends, is very very important. Okay, important parameters ఏంటంటే ఆల్వేస్ ఈ జీనా డయోడ్ అనేది కూడా పిఎన్ జంక్షన్ డయోడ్ లెక్కనే ఉంటుంది, బట్ ఆపరేట్ చేసేది మాత్రం ఎప్పుడు రివర్స్ బ్రేక్ డౌన్ ఆపరేట్ చేస్తాం. అయితే ఇది ఏ జీనా డయోడ్స్ మనం ఫ్యాబ్రికేట్ చేస్తామో దానికి డోపింగ్ అనేది కంట్రోల్ చేస్తూ మ్యానుఫ్యాక్చరింగ్ ప్రాసెస్లో బ్రేక్ డౌన్ వోల్టేజెస్ని మనం చెప్తాను మీకు నెక్స్ట్. ఓకే, ఆ బ్రేక్ డౌన్ వోల్టేజెస్ని ప్రిసైజ్గా వాడుతూ వీఆర్ గోయింగ్ టు డిజైన్ మై డియర్ స్టూడెంట్స్. ఓకే, వాటిని ప్రిసైజ్గా వాడుతూ మై డియర్ స్టూడెంట్స్ we are going to use it, my dear students. Okay, now here very very important thing is that how this particular, okay, the symbol is there, my dear students, and the operation. Carefully listen, my dear students, carefully. This is Zener diode. This is the Zener diode, my dear students. This is plus and this is minus. Okay, this is cathode and this is anode, my dear students. Okay, this is the Zener diode symbol. Okay, the symbol of the Zener diode, my dear students, and it is plus and it is minus, my dear students. Okay, and always I told you that the Zener diode is operating in which bias? That is in reverse bias. That also I am going to tell you here. Listen carefully, very very important. Listen carefully. This is the Zener diode. Zener diode, my dear friends. Listen carefully. What are the points I am going to explain are very very important. Later I am going to explain, my dear friends, the important steps also. Okay, the important steps also, my dear friends. Okay, very very important one. This is plus and this is minus. My dear students, the voltage that I am applying is V. Here the resistance here itself is R, my dear students. See here, this is the voltage across the Zener diode is VZ. Zener diode is VZ, my dear students. This is plus and this is minus. Okay, see here, listen carefully. ఇప్పుడు ఎప్పుడైనా కూడా when reverse biased, when I am going to do the reverse biasing, my dear students, when I am reverse biasing, if the reverse current of the Zener diode, okay, reverse bias చేసిన తర్వాత, if the reverse current of the Zener diode is limited using this series resistance, okay, the reverse current of the Zener diode is limited, my dear students, using this series resistance. అంటే రివర్స్ చేసినప్పుడు ఏమైంది, రివర్స్ కరెంట్ ఫ్లో అవుతుంది. ఓకే, ఈ రివర్స్ కరెంట్ వల్ల ఏమవుతుంది, మై డియర్ స్టూడెంట్స్, ఈ సిరీస్ రెసిస్టెన్స్ వల్ల ఈ యొక్క కరెంట్ అనేది లిమిట్ ఉంటుంది. This current is going to be limiting. Then the power dissipation at the junction, okay, the power dissipation at the junction is also limited, okay, which is also limited. So ఈ యొక్క junction లో పవర్ డిసిపేషన్ కూడా లిమిటే ఉంటుంది. ఎందుకంటే కరెంట్ ఏదైతే ఎక్సెస్ కరెంట్ వచ్చిందనుకోండి, ఈ కరెంట్ లిమిటింగ్ రెసిస్టర్, దీన్ని సిఎల్ఆర్ అంటారు. దీన్ని ఏం చేస్తుంది, ఈ సిఎల్ఆర్, this CLR, what is doing, my dear students, this CLR, okay, it is going to be limit that current. Okay, అప్పుడు ఏమైంది, ఇక్కడ ఎక్సెస్ ఆఫ్ పవర్ అనేది పోనప్పుడు ఏమైంది, this diode will not damage. This diode will not damage, my dear students. Okay, this diode is not going to be damaging over here, my dear students. Okay, that is one more important point you need to remember over here, my dear students. Okay, another important point is that see here, and Zener diode continues to operate safely in breakdown, okay, breakdown region. So breakdown region లో కూడా మనం కంటిన్యూస్ గా ఆపరేట్ చేయొచ్చు. అంటే మనకి ఏం లేదు, బికాస్ ఈ యొక్క కరెంట్ లిమిటింగ్ రెసిస్టర్ అనేది రక్షిస్తుంది, మై డియర్ స్టూడెంట్స్. ఓకే, సో వాట్ అల్టిమేట్లీ ఐఎమ్ గోయింగ్ టు టెల్ యూ, మై డియర్ స్టూడెంట్స్, ఈజ్ ఓన్లీ వన్ థింగ్. వెన్ reverse biased, if the reverse current of the Zener diode is limited, Okay, using a series resistance, then the power dissipation at the junction is also limited. Okay, then at such a level, the diode will not damage, and the Zener diode continues to be in a what, my dear students, operates safely in the reverse breakdown region, which is operating safely in the reverse breakdown region, my dear students. Okay, అయితే ఇదే నేను ఈ యొక్క డయోడ్ ఏం చేస్తాను ఇక్కడ, ఇది నేను ఉల్టా పెట్టాను ఈ డయోడ్ని, ఈ జీనా డయోడ్ని నేను ఇదేమో ఇటు సైడ్ తీసుకొచ్చాను, ఇది తీసుకొచ్చినప్పుడు ఇది ఇటు తీసుకొచ్చినప్పుడు ఏమైంది, నథింగ్ బట్ ఫార్వర్డ్ బయాసింగ్ అంటే సి ఇక్కడ ఏమైతుంది, ఫార్వర్డ్ బయాసింగ్ ఆఫ్ ద జీనా డయోడ్ ఈజ్ సిమిలర్ టు యాజ్ ఏ కన్వెన్షనల్ డయోడ్. ఫార్వర్డ్ బయాసింగ్ ఏం చేస్తాం, జీనా డయోడ్ ఈజ్ సేమ్ యాజ్ ఏ కన్వెన్షనల్ డయోడ్. ఓకే, బట్ ఇన్ రివర్స్ బయాసింగ్ ఇట్ ఈస్ ఆపరేటెడ్ ఇన్ వాట్, మై డియర్ ఫ్రెండ్స్? It is operating in the reverse breakdown region, my dear friends. Okay, reverse breakdown region. Generally, how many types of breakdowns are there? Already మీకు చెప్పాను, but ఇక్కడ I am going to tell you in a overall summary. Okay, I am going to tell you, my dear friends, okay, in a overall summary. My dear friends. Okay, what is that? ఓవరాల్ సమ్మరీగా చెప్తానా, మై డియర్ స్టూడెంట్స్. ఓకే, వెరీ ఇంపార్టెంట్ దిస్ సమ్మరీ. అంటే జనరల్గా ఎన్ని టైప్స్ ఆఫ్ బ్రేక్ డౌన్స్ ఉంటాయని మీకు ఆల్రెడీ ముందే చెప్పాను. ఓకే, ఒక్కసారి మీకు ఏమైనా డౌట్ ఉంటే బ్యాక్ వెళ్ళేసేసి బ్రేక్ డౌన్ మెకానిజమ్స్ చెప్పాను, అక్కడ చూసుకున్నాను. వీ నీడ్ టు సీ ఓవర్ దేర్, మై డియర్ స్టూడెంట్స్. See over there, my dear students. So that law very important. Just I am giving the summary, my dear students. The important summary, 5 points only. First point, second point, third, fourth and fifth points. This is 1, 2, 3, 4, 5, my dear students. Okay, how many breakdown mechanisms are there? One is Zener breakdown, second one is avalanche breakdown, my dear students. Okay, ఈ breakdowns గురించి ఆల్రెడీ మీకు చెప్పానా, how we are going to get. Okay, breakdown ఎందుకు వస్తుంది ఇక్కడ, ఈ breakdown is due to, సింపుల్గా చెప్తాను, అప్పుడు ఏం చేస్తాం మనము, ఇంటెన్స్ ఎలక్ట్రిక్ ఫీల్డ్ అక్రాస్ జంక్షన్, అంటే హై ఎలక్ట్రిక్ ఫీల్డ్. ఓకే, ఇంటెన్స్ ఎలక్ట్రిక్ ఫీల్డ్ అక్రాస్ ద జంక్షన్. This is what, my dear students, breakdown because of what, my dear students, collision of what, my dear students, charge carriers with atoms. Okay, so here due to what, my dear students, carrier multiplication or amplification of carrier multiplication, this thing is happening, my dear students, due to carrier multiplication, my dear students. Okay, occurs for the Zener voltages. Always what kind of voltages, my dear students? The Zener voltage always Vz occurs. This particular breakdown occurs only when the Zener voltage is less than 6 volts. Okay, here the Zener voltage is greater than 6 volts, my dear students. Okay, greater than 6 volts, my dear students. Okay, here what happens, the temperature coefficient, is, okay, negative. Here the temperature coefficient is positive, my dear students. Okay, ఇక్కడ ఏమైతుందంటే బ్రేక్ డౌన్ అనేది ఎప్పుడు ఏమైతుంది, ఇక్కడ ఇన్వర్స్లీ ప్రపోర్షనల్ టు టెంపరేచర్, my dear students. Okay, ఇన్వర్స్లీ ప్రపోర్షనల్ టు టెంపరేచర్ అంటే ఏమైంది, ఇక్కడ టెంపరేచర్ పెరుగుతున్న కొద్దీ బ్రేక్ డౌన్ వోల్టేజ్ ఈజ్ డిక్రీజెస్. ఇక్కడ breakdown is directly proportional to, breakdown voltage is directly proportional to the temperature. అంటే ఇక్కడ టెంపరేచర్ పెరుగుతున్న కొద్దీ breakdown voltage పెరుగుతుంది, my dear students. Okay, the breakdown voltage is going to be increasing, my dear students, over here. Okay, now here VI characteristics, okay, sharp in the breakdown region. See here, VA characteristics always sharp in breakdown region. Because not sharp. The characteristics are not sharp, my dear students. Okay, the breakdown mechanism generally how we are going to occur, my dear students, I have depicted over here. Okay, so the breakdown mechanisms are because of these particular things over here. Okay, these are all the general parameters. Just I would like to bring it to your notice, my dear students, before entering into the next topic over here. Okay, similarly, okay, my dear students, okay, very important. Okay, so now we are going to study the very important parameters. Okay, అంటే ఇవన్నీ మీకు జనరల్గా ఆల్రెడీ ఈ యొక్క డీటెయిల్డ్ బ్రేక్ డౌన్స్ గురించి నేను ప్రీవియస్ రికార్డింగ్స్లో చెప్పాను అలా. వన్స్ అగైన్ నాట్ టీచింగ్ దోస్ పర్టికులర్ థింగ్స్ ఓవర్ హియర్. ఓకే, సిమిలర్లీ what are the VA characteristics of this particular Zener diode? VA characteristics of this particular Zener diode. Zener diode by VI characteristics. If I am going to take it, this is a forward current, forward voltage, reverse current, reverse voltage. This is forward current, forward voltage, reverse current, reverse voltage, my dear students. Okay, ఫార్వర్డ్ క్యారెక్టరిస్టిక్స్ అంటే ఇక్కడ చూసాం కదా మన యొక్క క్యారెక్టరిస్టిక్స్లో, ఫార్వర్డ్ క్యారెక్టరిస్టిక్స్లో దీన్ని చేంజ్ చేస్తే ఫార్వర్డ్ బయాసింగ్లో సేమ్ క్యారెక్టరిస్టిక్స్ ఆర్ వాట్, మై డియర్ స్టూడెంట్స్, సిమిలర్ టు ద నార్మల్ డయోడ్, similar to the normal diode. So what is happening, my dear students? Here the characteristics are similar. These are similar to the normal diode. Similar to the normal diode. Then what happens, my dear students? Okay, see, in forward bias, the normal diode and Zener diode both operate in similar fashion. Okay, ఇక్కడ Zener diode గాని, my dear students, normal diode, both operations are similar. So normal diode already చెప్పాను కాబట్టి no need of discussing again, my dear students, over here. Okay, similarly here what happens when reverse voltage is applied to the Zener diode. Okay, when the reverse voltage is applied, my dear students, listen here, reverse voltage apply chesa means I am applying the reverse voltage, my dear students, like this. Okay, to the Zener diode, initially the current is okay, is small, which is called reverse saturation current. Okay, initially the current is very small. Chudandi, ee current very small, my dear students. Okay, current is very small means when I am applying the reverse voltage, okay, apply to the what, my dear students, to the Zener diode, initially the current is very small, my dear students. Okay, later what happens, okay, which is called reverse saturation current. The name antanana, we are going to call it as a reverse saturation current, my dear students. Okay, reverse saturation current. Okay, after certain voltage, okay, ikkada after certain voltage Vz, what happens, my dear students, means here what happens, the reverse breakdown, okay, occurs. Okay, when reverse breakdown occurs, automatically what happens, the current in the Zener diode increases rapidly. The current in the Zener diode increases rapidly, my dear students. Okay, current in the Zener diode and e voltage tarata, okay, increases rapidly, my dear. The sharp change is called Zener current. ఈ కరెంట్ ఏమంటారన్నా, see, ఇది ఒక నీ పాయింట్ అంటారు. ఈ పాయింట్ ఏమంటారు, దిస్ పాయింట్ ఇస్ కాల్డ్ నీ పాయింట్. knee point, my dear students. Okay, this point itself is called the knee point. Okay, knee point, the sharp point in the Zener current, okay, is called, ఇది ఏమంటారంటే knee point, minimum current అనమాట. ఇది IZ min అని కూడా అనొచ్చు. దీన్ని knee point ని మనము minimum current అని కూడా అనొచ్చునా, knee current అంటారు దాన్ని. ఓకే, ఆ knee current కూడా మీకు తర్వాత చెప్తాను. very important, my dear students. Okay, listen carefully. Okay, so here the sharp current, okay, change in the current, Zener current is knee current or knee. Okay, Zener knee and good. Okay, knee, that is a knee point, or simply we are going to call it as knee, or we are going to call it as Zener knee and good. Zener knee. Ikkanchi sloga, my dear students. Okay, operating in Zener, operating region is called Zener region. This is what, my dear students? Operating region is called Zener region. Is called Zener region, my dear students. Okay, is called Zener region. Okay, and this particular operating region is called what, my dear students? Zener region. Okay, either a knee point, my dear students. Okay, in the reverse breakdown, VZ remains constant though current increases up to certain limit. Okay, ఇది మాత్రం constant in ఉంటుంది. Okay, Zener voltage remains constant even though the current is increasing. The current increase అయితేనే ఉంటుంది. The current is increasing, my dear students. Okay, after certain reverse voltage only. Okay, ఒక certain reverse voltage of the breakdown occurred, but it is constant, but the current is increasing, my dear students. The current is increasing. Okay, the reverse bias voltage at which the breakdown occurs, ఈ voltage దగ్గర the voltage occurs is called Zener breakdown voltage అంటారు. The voltage where the breakdown occurs is called Zener breakdown voltage. అంటే VZ is called Zener breakdown voltage. Zener breakdown voltage, my dear students. Okay, so generally for Zener diodes only two currents are there, my dear students. Okay, what are that currents? Okay, very important currents, my dear students, and the formulas also very important. Okay, these using these particular formulas we are going to solve the problems based upon this one. Okay, we are going to solve the problems based upon these things, my dear students. Okay, so how the previous year question definitely, and the coming years also one definite question will be asked from the Zener diode. Okay, what are those particular, okay, Zener diode practically two currents are specified. What are those currents? Okay, for Zener diodes, my dear students, practically two currents are specified. Two currents are specified practically. Only two currents has been specified, my dear students. Only two currents has been specified. One is IZ min. Okay, IZ min. Okay, which is equal to IZ min. IZ min ante the minimum current through the Zener diode. The minimum current through the Zener diode. Okay, so the minimum current through the Zener diode to maintain its reverse breakdown operation. Okay, so using this particular current to maintain the what, my dear friends? To maintain the its reverse breakdown operation. Okay, another is one more current, IZ max. Okay, this is what the maximum current, my dear friends, where the Zener diode can safely maintaining its and minimum ikkanchi manam start cheyochu maximum current. Okay, to maintain, my dear friends, maximum current, my dear friends. Okay, where the Zener diode is maintaining safely in reverse breakdown operation. Where Zener diode, my dear friends, can safely maintaining in my dear friends. Okay, safely maintaining in what, my dear friends? Reverse breakdown operation. Reverse breakdown operation, my dear friends. Okay, always these two current plays a vital role, my dear students. Okay, so here what happens always, if the reverse current exceeds this value, ఈ maximum current exceed అయిపోయింది అనుకో ఏమైంది నాన్న, ఆటోమేటికల్లీ ద డయోడ్ మే గెట్ డ్యామేజ్డ్ డ్యూ టు ఎక్సెస్ పవర్. సో ఇది మినిమం ఉండాలి, ఇది మ్యాక్సిమం ఉండాలి నాన్న. ఇట్ ఈస్ అ minimum and maximum, my dear students. Okay, so in the next class I am going to continue about these particular things, my dear students, in a detailed manner. Okay, here what happens, the current IL, okay, IL min formulas also, the minimum current equal to, okay, which is equal to I లోడ్ లో ఇది చెప్తాను ప్రాబ్లమ్స్ వచ్చినప్పుడు, I మైనస్ IZ మ్యాక్స్. ఓకే, లోడ్ మినిమం ఉండాలి. సో హియర్ IL max equal to I minus IZ min, my dear students, IZ min. And using these particular formulas, in the next session I am going to explain, my dear students, the very important problems on this particular one. Okay, and in the next class, my dear students, we are going to study about the important things. So the currents, how these current equations are there, and what is the equivalent circuit of the Zener diode, my dear friends, and what is the Zener diode readings, and the different problems, applications of the Zener diode, and the previous year questions, all these particular things I am going to finish one by one in the next class, my dear students. Okay, hope that you have enjoyed the today's session, my dear students, in a very beautiful manner over here. Okay, finally, okay, thank you very much for attending the today's session, my dear students. As I told you that the number of the followers in the Facebook and Instagram and Telegram as well as the Unacademy is concerned is daily is increasing, my dear students. Okay, second part is Unacademy Telugu channel. You are going to access the subject in two languages, Telugu and English, my dear students. Okay, Telugu and English. And my dear students, the very India's #1 study channels also there, my dear students, where you are going to access, okay, different competitive level examinations for different subjects, my dear students. Okay, and finally, thank you very much for attending the today's session. Finally, thank you very much for attending the today's session, my dear students. Okay, okay, is that clear over here?